Hey, this is Mr. Barr, and this is the pretest for quadratics. So the first question is identifying different parts of the quadratic. So I want to know where the minimum is. Well, the minimum's right down here. This is the minimum. And that's occurring at -1. Where's the vertex? Well, the vertex is this point right there. And that's occurring at 1, -1, 1, -1. Where's the y-intercept? The y-intercept is right here. And that's occurring at 0. You can't see what I'm doing. Axis of symmetry is right here. And that's at x equals 1. X equals 1 for my axis of symmetry. So just identifying all the parts of a graphed quadratic. What are the two answers to this equation? So x squared equals 81. So both 9 squared would work and -9 squared. 9 squared is 81, -9 squared is 81. How many real solutions does this have? Well, I'm going to solve this equation, and to solve it, I'm going to start by adding 10 to both sides. So right here, I added +10 +10, so it took me to x squared equals -36. At that point, I realized there's no real solution. Why? Because you can't take the square root of a negative. No real solution. If this was x squared equals 36, well then it would have +6 and -6, two real solutions. But since I can't take the square root of a negative, not yet, you'll learn how to do that next year. But right now, that means there's no real solution. Solve this using the zero product property. So if I need this piece to go to 0, so x plus 3 has to go to 0. Well, that would be -3. -3 plus 3 is 0. So there's one of my answers. Here, I need it to go to 0. So 5 minus 5 equals 0. So the answer is 5. So when I'm using the zero product property, I want each piece, each factor of this to go to 0. The next one is similar to the previous one, except I have to factor it first. So here's x squared plus 7x plus 12, which factors as x plus 4, x plus 3, right? X squared, 12, 4, and 3 gives me the 7. Once I've factored it, I'm going to use zero product property. So what makes this piece go to 0? A -4. What makes this piece go to 0? A -3. Those are the two answers to the equation. Two solutions. Here's another one. It's already factored, so we're going to use zero product property on both of these. So I need this piece to go to 0. I need that piece to go to 0. So 2x plus 3 equals 0. 2x plus 3 equals 0. Subtracting 3 from both sides, dividing both sides by 2, I get x equals -1.5. X equals -1.5. I take the 4x minus 5, 4x minus 5, and set that equal to 0. 4x minus 5 equals 0. Adding 5 to both sides, dividing both sides by 4, and I get 1.25. So these are the two answers that if you plug them in here, would make this go to 0. If you plugged in -1.5, it'd go to 0. If you plug in 1.25 in both places, it would go to 0. Number 7, I need to factor it first and then use zero product property. So right here, I can see that I can factor out a 2x. So I factored out the 2x right here. So 2x times the quantity 4x plus 5 equals 0. I'm going to set both these pieces equal to 0. So 2x equals 0, which means x equals 0. 4x plus 5 equals 0. Solving that, x equals -1.25. So I factor it, and then I use zero product property. That was number 7. Number 8, same idea. I factor it, and then I use, factor it and then use zero product property. So right here, I factored it. What makes this piece go to 0? -1/2 makes it go to 0. What makes this piece go to 0? -6 makes it go to 0. Factor it, zero product property. This one I used the quadratic formula on. Quadratic formula is listed right here. Negative b plus or minus the square root of b squared minus 4ac all over 2a, where this is a, b, and c terms. So I plug in my a's, I plug in my b's, I plug in my c's, I turn the crank, and I see what comes out. So I plugged it all in, and I got it down to right about here. I got it down to negative 68 plus or minus 52 over 32. Once I got to here, I actually split it into a positive equation and negative, so negative 68 plus 52 over 32, and negative 68 minus 52 over 32, and I solved both of those. Answers turned out to be negative 1/2 and negative 3.75. And that was the last question. Thank you for watching. Have a great day.